Hello and welcome to today's lab. Within your VCL session, navigate to the Blackboard course webpage for Government 300. Along the left-hand menu, select Data, and choose the NAS 2008 dataset, and this will prompt either Open or Save. Click Open, and you'll open up a session of SPSS. Building off of both the t-test video and the ANOVA video, this video shows how to construct appropriate graphics for both of these tests. For t-tests and ANOVA, a box plot is the appropriate graphic because a box plot arrays our independent variable, or our subsample distributions, along the x-axis and our dependent variable on the y-axis. A box plot will depict the central location and dispersion for each subsample. This allows us to compare cross-subsamples of the total distribution of our dependent variable. First, let's build a box plot from the t-test we did in the t-test lab video. Recall from that video, we hypothesized that women would rate Obama higher on the feeling thermometer than would men. Alright, so let's take a look at that t-test. Click on Analyze, Compare Means, Independent Samples t-test, and we're going to sort our variables. Navigate first to the dependent variable, the Obama thermometer. Place that in the test variable box, and then gender, which is our independent variable. We're going to place that into the grouping variable box. And recall that we have to define our group numbers here. So group 1 is 1, and group 2 is 2. Click Continue, and then click OK. Recall from our t-test lab that this relationship is significant. On average, women rate Obama higher on the feeling thermometer than do men. In the statistics box, we see that these two subsample means are different, and our t statistic and the associated p-value tells us that we could make a claim from our sample to the population. Alright, so minimize that output. So now let's depict this relationship in a box plot. Go to Graphs, Legacy Dialogues, and then choose Box Plot. Make sure Simple is selected and then click Define. Alright, and sort your variables again. And we'll navigate first to our Obama thermometer. The dependent variable, place that into the variable box, and then gender, which is our independent variable, will go into the category axis box. Alright, go ahead and click OK. Alright, this generates a box plot that arrays our two subsamples, male and female, along the category axis with our dependent variable on the y-axis. Remember that box plots organize our subsamples using a 5-number summary. The low value, Q1, our median for each subsample, Q3, and our high value. Now we can get a sense for how these subsample distributions compare. While the medians appear to be the same for these two subsamples, the higher Q3 value, around 85, in our female subsample indicates that the middle 50% of our cases fall higher on the feeling thermometer for females than males, around 75. Alright, so minimize that output. Alright, so now let's do a box plot for the ANOVA calculation we performed in our ANOVA lab video. Recall that we hypothesized that, on average, high church attenders were more likely to favor a decrease in government spending than would low and medium church attenders. So let's take a look at that relationship again. Go to Analyze, Compare Means, and we're going to select one-way ANOVA. We're going to once again sort our variables here. And our dependent variable is the variable called spend 10. We're going to place that in the dependent box. And our independent variable is relig attend in 3 categories. We'll place that into the factor box. Go ahead and choose the post hoc button, and we're going to select the 2-key post hoc correction. Click Continue. and then click OK to run our analysis. All right, recall from our ANOVA lab that this relationship was significant, but not in the direction we specified. While the overall F statistic indicated that we could reject the null hypothesis, we found that the middle church attenders were more likely to favor higher government spending than high church attenders. Recall that we determined where this statistically significant relationship existed by running our post hoc correction, or Tukey. All right, great. Now let's depict this ANOVA in a box plot. So exit out of this output. And we're going to go up to Graphs, Legacy Dialogues, and back down to Box Plots. Make sure Simple is selected, and click Define. And we'll take our old relationship out of there. And we're going to place our spend 10 variable into the variable box. And then our religiotend 3 into the category axis. And click OK. All right, remember again that box plots organize our subsamples using a five-number summary. The low value Q1, median Q3, and our high value from bottom to top. In the t-test box plot, we were only looking at 2 subsample means. Now we're looking at 3 subsamples, 1 for each category of our independent variable. Remember that the Tukey post hoc test indicated that the only relationship that was significant was between high church attenders and middle church attenders. Looking at the central location and dispersion for each subsample in our box plot, we can now see that high church attenders and middle church attenders are the furthest apart here in the box plot, with high church attenders Q1 at 2 and Q3 at 6 with a median of 4, and middle church attenders Q1 at 3 and Q3 at 7 with a median of 5. In the far right subsample of low frequency church attenders, you can see that this subsample falls between the high and middle subsample and depicts that what the Tukey correction found, that differences between low church attenders is not statistically different than either our high or middle church attenders.
You're doing terrific, students. This concludes our section on categorical independent variables, including dichotomies and interval or ratio level dependent variables. When you're ready, let's move on to the next section, which starts with correlation and bivariate regression. Do both the readings before watching the videos.